Right. So good evening, and also good morning, for friends in America. So welcome back to RoboCup at Home Education Online Classroom, and today we have the first invited lecture series for 2021. I welcome you. So today I'm Jeffrey, and together with me are our colleagues from MathWorks. So together we will bring you for the today's topic, getting started with the RoboCup Virtual Manipulation Challenge. Okay, and here are some details, but I'll go through the details. So please give me about 5 minutes time to do the introduction. Then we will invite our invited guest for the talk. Okay, so this is the arrangement for today invited lecture. The topic, getting started with the RoboCup Virtual Manipulation Challenge, and our speaker is from MathWorks, Nobu Iijima-san, and also there are a few fellow colleagues from MathWorks as well. So just in case, like if you have more additional question, so we have a few engineers from MathWorks here ready to answer your question. Okay. Then, as down there written, so we will start at 7:30 in Malaysia and China time, and in New York there is early in the morning, and also if you come from Europe, it's 1:30 in the afternoon. Right, and you can find a QR code at the right-hand side, so that QR code will link you to an interactive Q&A page, which looks something like this. Let me show you. Okay, so if you access to that link, you will come to this page. Okay, so and from this page, you can find the link to our, for example, the website for this invited lecture series, and also our course materials. So including the slides that I show in front of you, which is this one. So this slide and the rest of the information, which is, for example, the video that we record today, will be up there, and also all other related materials later on. For example, like the source code or any links, any information regarding this invited lecture will be up and will be ready there for you to refer after the class. Okay, so for the meantime, please access to this page for the Q&A page, so that if you have any question, you can use this page to put down your question, and we will try to answer you whether like during the session or after the session as well. But also, if let's say you have anything you want to ask after this, we finish the presentation, we will have an interactive Q&A session, so you can also ask over there. But I would suggest please put down your question along the way, so that we can get ready to answer. Okay, so please access to this page so that you can get all the information and you can ask question over here. Okay. Right. Okay, so before we start, please be reminded that the whole session will be recorded into video, and the video will be published online, which is whether at the course materials website just now that I just mentioned, and it will be also for like some promotional materials, like for our YouTube videos and all other events. We will also put up this video. So for this reason, please refrain from turn on your webcam and also your microphone unless you are told to do so. Okay, thank you for your cooperation. Okay, so before we start the invited lecture today, so I would like to take about 1-2 minutes to introduce us, which is the RoboCup at Home Education. So today we actually host this event together and invited our speaker from MathWorks to show you some related activities within our initiative. Okay, so let me introduce our initiative. So RoboCup at Home Education is an educational initiative in RoboCup at Home, or RoboCup, that promotes educational efforts to boost our participation, which is a competition participation, and also artificial intelligence focused service robot development. And under this initiative, currently we have 4 efforts which is in operation, active operation. So the first one is RoboCup at Home Education Challenge, which is very closely related to the topic today. And also currently we are running the online challenge 2021. So later on, I'll give you more information about these activities. The second one is we promote open source educational robot platform for RoboCup at Home, which is in this case, we also collaborate with MathWorks to show you how to develop service robot. Not just the hardware development, but also with MathWorks, we actually try to help you, and also we actually develop a lot of source code, software and resources to help you for your robotics development, which is, you will find the link later on. We will share with you the information, which is also related to the talk today. Okay, and the third one is open courseware. So we prepare all those source code and all the development resources. We are actually also try to transform them into some teaching and learning materials for the learning of AI-focused service robotics. So later on, we will also share with you some source code that we have developed with MathWorks that help you to develop your robot development, which is, you can find that particular resources on GitHub, which is open source. So that is the open courseware, and also the materials that you can is available for free for you that you can download from the internet. Okay, and also this year we started one collaborate with Robot for All website to host all our course materials. So that's why including the materials for today are hosted over there, so that you can have a very complete environment for you to learn and also refer to our materials. Okay, and lastly is the outreach program. So today is one of our outreach program, which is we will organize this kind of event, and also in future we will organize more of this kind of talk. So please join us. We will have more of this kind of program to outreach our materials to the general public. Okay, so for more information, you can access to our website. You can find more information. Okay, so before I end this introduction, I would like to say thanks to all our sponsors, which is down there, especially MathWorks, that today we collaborate for this talk. Okay, so under our online classroom, so we started our online classroom 2020, which is also in conjunction to all the global changes to all online activities. Then under our online classroom activities, we actually have a few more series. So including today, we have the invited lecture series. But apart from this, we actually conducted several online challenge tracks. So every year we have this online challenge running on starting from 2020. So you can see down there are two links. So one online challenge 2020, and this year we are actually running the online challenge 2021. Okay, and for this online challenge, because of our educational focus, we are not just running the competition, but before that we actually run a series of online classroom, which is to show to you, to share with you our materials to learn how to develop robots, including how to use MathWorks to develop robots. So if you are interested to find out more information about all this, or if you want to join the class in future, so please, you can head to our website, which is, I have put the link over there to find out more information. And from there, you also can link to our resources, which is like, for example, you're interested to see the video. So we have the recorded video over there. The slides that we use for the online classroom is over there as well. And including all the source code that we use as, for example, is also over there, right? And for online tutorial, so we also know that just giving you the materials might be not enough, because like you might have a lot of questions that you want to ask, you have some problem, error. So we actually also run some online tutorial. We have, we already run for this year, 2 sessions. You can find the materials again from our website. And also we have our regular online classroom track, which is we run all along the year. In some time interval, so you can find out more information for all these things on our website. So lastly, apart from our official website at robocup@home.edu.org, we now collaborate with Robot for All, which is another website that hosts for our learning materials and also our community site. So if you want to interact with us, you want to like get more materials, please visit robotforall.net. You can find a lot of information there, and also you can join the community group over there so that you can interact with our community. All right, okay, so I hope to see you over there, and please feel free to utilize the resources that we provide online. Okay, so right, okay. Okay, so we are going to start the talk today. So before that, I would like to introduce the speaker. So today we are very honored to have Nobu Iijima-san from MathWorks to share with you the topic that I mentioned before. But now let me read the profile for Iijima-san. Okay, so Nobu Iijima is an automotive engineer from MathWorks, specialized in the area of automotive education and student competition. So other previous experience, including modeling and simulation of a new type of electric brake called magnetro-halo vehicle. Okay, so maybe let Iijima-san to mention this again. Brakes that adapted for environmental needs and also automatic driving technology. Okay, and also we have other colleagues from MathWorks today. So maybe Iijima-san can also introduce your fellow colleague before you start your presentation. Okay, so now let me introduce our colleague from MathWorks and also invite Iijima-san for the presentation. So I will close my display and I'll pass the mic to Iijima-san.
Can you see my screen?
Yes, I can see your screen, and please introduce yourself and also your colleague, then you can start your presentation. Thank you.
All right, thank you. So welcome to our webinar. I'm Nobu Iijima, working at MathWorks Japan, especially for student competition teams. And yeah, and all right. So we also have Fred from industry marketing working at Japan office, and Jose is also working for student competition from US office. Right. So we are going to be delivering this RoboCup webinar for Virtual Manipulation Challenge. So what we are going to be covering today is this. Basically, we are going to talk about the outline and guidance of the challenge. First, we are going to talk about what the challenge is, including problem statement and virtual robot environment used for the challenge and scoring. I will tell you how you can get the high score. And then rules, and we prepared some templates for getting started. We are going to show you where you can get the hands-on. We will do simple demonstrations with MATLAB Simulink and how to program the robots for this competition. And finally, I will give you the details of how to register and participate and submit all your work. If you have any questions, please feel free to ask them in the chat box. We keep the time to answer your questions at the end of this presentation. We will start with the problem statement, and the idea behind this challenge is that manipulation is a common robotic task that is necessary for most RoboCup leagues, and robotic manipulation. It is a skill that is necessary to a lot of robotics applications. So the problem for this challenge is to use MATLAB Simulink to sort bottles and cans into their respective bins. So our task is to recycle some bottles and some cans in a virtual environment. And after you complete this challenge, the skills which you will gain are developing algorithms of both perception and control. We will provide test environment to develop your algorithm. And there is a set of rules of environmental behavior. Those rules will be explained later on during this presentation. And finally, the scoring will be performed in an unknown environment. And the prize for participating in this challenge is 3 RoboCup Federation grants for up to $5,000 US. So when you get to the finals and get top 3 positions, then you will be given research grants for the next cycle of the RoboCup competition up to $5,000 US. The virtual robot environment provided for this challenge is the Gazebo environment, which will contain the Kinova Gen 3 robot. And you can see them on the screen. All the bottles and cans are placed on the table. You are supposed to pick and place them into the target bins, which are in respect to the blue and green. this bins, right? And then finally, the table also has a set of obstacles to make a problem difficult. Here are some of the conditions that are followed by the environment. If you see the game field from the top view, it is splitting into different sections. And the sections correspond to this different condition. In this case, you can see those gray areas on the top and bottom of the screen picture. In both of those gray areas, the items will not change. It is always going to be in the same items, positions, and orientations. So you can consider writing a coding algorithm for it. And in terms of scoring, you can get some safe points with them because those items are always the same place orientation and always in the same item. Then, right in front of the robotic manipulator, you can see the orange or yellowish area in which the shape of the items can change. So what that means is, for example, you can see there is a couple of bottles and cans in a specific location and orientation. Those cans might change state to bottle and vice versa. So algorithm should be able to treat for this change. Then we have this blue section on the top left corner of the picture. Inside of the wood box, there are a couple of items. This is called random item bin. And in the random item bin, what we are going to have is a selection of items that are going to be placed in there at the random orientations and positions. So the items are always be the same items, but they will change the position and orientation. And then last section we have is the section where the items will always be in the same location, but the orientation might slightly change, which includes these bottles and cans within the brown section in the picture. Here's an example of two different configuration that we are providing an example models. For instance, you can see the environment on the left on the red highlighted box that the red bottles is sort of laying on its side, whereas the environment on the right is the same position, but it's standing up straight. And the same for the sort of the green region highlighted here, you will see that from top to bottom, the items used to be left are bottle and can and bottle. And then on the right item change to a can, a bottle, and a can. So it happens. And again, these rules will be respected in the previous sections that we outlined. The different points are awarded in the challenge based on the difficulty of the grasping beam problem. For instance, you will notice that there are three major levels of difficulty which award 10, 20, and 30 points, respectively. The items that are worth 10 points are closer to the manipulator. They have fewer variable conditions. The items that are worth 20 points are harder to reach places. For instance, you can see that some of them are within the boxes, so you might have to avoid obstacles with the specific grasping approach. And then finally, we have the third set of difficulties items. For instance, an item is surrounded by the wooden blocks. Some manipulation of the other activities is required before you pick and place the target object. And some of them are difficult because the objects are really close to the edge of the table and it might fall down to the ground. The way that the challenge is scored is with the scoring rubric that we are sharing in advance. Everything is on the challenge homepage, so you already have access to this and you will obtain points for different things. one of the sections to get points is submitting all your model and algorithm correctly. It is very important that you test your algorithms because we will be testing those algorithms in the third unknown word. So by making sure that you have a reproducible model in MATLAB, and you will be getting 5 points by submitting a video of your algorithm in the virtual world performing the desired behavior program. And then on our side, when we will reproduce your file without errors, you will be awarded 20 points for providing everything necessary. And we will provide some links of tools that can help you determine whether or not you provided all files. And of course, if you are part of the team, the best test would be to share the file package with your team members and make sure that you can run it on different computers. Then the robot is equipped with different sensors, which are an RGB camera and depth image camera. Depth image camera will be providing you with information on the distance proximity of the objects. By using each of these sensors effectively, you can earn to 40 points for each. And the condition here is that pick and place tasks performed on an object will have to be a product of an algorithm based on those sensors. For example, identifying the color of an object, such as determining that it is green, or the shape determining if it is a bottle or can, and putting it in the correct bin. If you use the camera to make that classification, then you will be awarded 40 points. Then this is the sort of the most important part of the scoring, which is how many points are awarded by the different objects on the field. So you can see here that the cans should go into the green bin and the bottles should go into the blue bin. And for each successful classification of the green cans, you will be awarded 10 points. You will get 20 points for the yellow cans and 30 points for the red cans. And then the same scheme applies to the bottle. Each should be correctly classified. If you put the blue bottles in the blue bin, you will get 10 points, 20 points for yellow bottles, and 30 points for red bottles. Now there is a couple of other scoring items. There are deductions in case that you place the item in the wrong bin. That would be 10 points reduced from your total score. And if one of the items from the table falls on the floor, you would lose 5 points. There are also 30 bonus points that can be awarded. First, if your robot lifts at least one item from the table from this specific shape change region, which is yellow color section in the previous slide. So the region by the front of the robot, you are able to lift it from the table and hold it, then you will be awarded 10 points. And secondly, if you are able to retrieve an item from a random item bin, which was a blue section in the previous slide, regardless of the end location of the item, if you are able to retrieve it from the random item bin, you are also awarded 20 points. There are some additional rules. As a rule, it is important to provide all the necessary MATLAB Simulink files so that your algorithm can be reproduced in some third unknown environment by us. And that your perception algorithm does not use information from the Gazebo API. There is a connection directly through the API, which is sort of like a magical way to changing the position of an object. One of the rule of challenge is that don't use the functionality, otherwise you can be disqualified. Objects must be the reaction of interaction with other environmental components. What this means is basically the objects must be moved by the manipulator itself and do not use Gazebo API to set positions or states. Of course, we are providing a virtual machine that has all the relevant environments. Make sure not to modify the virtual machine provided. Otherwise, you might be at disadvantage when you develop your algorithms, since we will be testing them on the same version that is provided for the challenge. And finally, another rule is the robot start position should be the same as in the templates provided. Since there might be an extra initialization period if you are trying to start from the different robot configuration. And again, it is for you not to be at a disadvantage. There is some code available for getting started so that it is not necessary to start in MATLAB and Simulink from scratch. So we have some templates for this challenge that are already published on GitHub, which gives you the interface to the virtual robot itself. This interface is a ROS interface through MATLAB and Simulink. And it will also have a complete algorithm showing you how to perform control for the robot manipulator in order to navigate to the desired position with the gripper. So we are going to be covering those in details right now. Now there are provided instructions for getting the virtual machine set up with the virtual environment. And after you follow those instructions, which are available in the GitHub repo, you will open your VMware player and open the provided image. In this case, you will see that we have already added our VMware player sets ROS melodic dashing gazebo here. And this is a virtual machine in Linux setup with everything necessary for the developing for the challenge. We will play the virtual machine, so we will get it loaded up and started. And you will see that Linux environment will come up on the virtual machine window. And here we will see the folder on the desktop that says RoboCup challenge where the test environment are stored. And you will also see the IP address of your machine, which is going to be important in order to set up the connectivity between your host computer and your virtual machine. If you click the RoboCup folder on the desktop, you will see the two shortcuts to the example words or the example environment. And you can click on either of them to get them up and running. And once you click on it, the Gazebo will get started with all the necessary topics and actions and service to control. You can see the Gazebo window and the graphical interface with the environment. Now we are going to go into the MATLAB demo, which is the template available within the files provided in that GitHub submission. It's a MATLAB live script, and you will see how we are going to control in this video. We will be controlling the X, Y, Z positions of the gripper manipulator in order to move in a respective direction. So in the video, you will see that we run the MATLAB live script from the tool strip by hitting play button, and you will find lots of resources on this live script as well. You can see in the command window that MATLAB starts sending trajectory for the robot to travel to. And on the right in the Gazebo environment, you can see manipulator lowering its gripper to the desired position very, very slowly here. And this is determined on the speed of the trajectory that we have set. Now, as you get the feedback, on the MATLAB command window, you will see that the trajectory points are still being sent, and then it stops, which means that it's got into the desired location. And you can see in our MATLAB script here that we can set the gripper X, Y, Z positions as well as that location in each of the relevant axes. In this case, we've gone for the individual axis, but you can also use a generalized transform in order to set this type of condition. And all right. We are going to now use this live script slider in order to change the gripper Z position. And while we do that, we will see that we've raised the gripper, and the MATLAB script will start sending the new sequence of trajectory command of the new waypoints for the configuration of the robot. And this is available for all participants to reuse, so that they can immediately control the coordinates of the gripper. And here we can see that gripper is being raised by a small amount. So, and then now we are going to see what happens if we try to open and close the gripper, which is also controlled by the ROS action client. So we are interesting through the ROS operating system. We are communicating with the virtual machine, and in this case, we are opening and closing the gripper. And if you watch closely, all right, on the right on the virtual environment, you can see the gripper is now closed. Here, the gripper is now closed. Right. And then here we have an image that was acquired from the virtual camera provided in the robot. And we've received the image which is pointing in the direction of the gripper. And we can see the objects are right in front of the robot. These are the image that you can process in order to make decision for your robot. And then if we scroll a little bit down on our MATLAB live script, you will see that we can also subscribe to the ROS topic that contains the depth image. In this case, we will see the grayscale image that corresponds to the distance that each of these pixels is away from the camera. And now we are going to show you Simulink. If you are not familiar with Simulink yet, Simulink is MATLAB simulation environment. You will be able to design algorithms that will interact in a more real-time fashion. And you will also be able to design algorithms that run in a closed loop. So in this case, we are going to be showing you how to do similar control of the robot. But we are going to be using Stateflow, which is a state diagram graphical environment, in order to schedule the different tasks for the robot. In this case, we are programming a sequence of command for this robot. So here on the left, so we see Simulink model, and we can see in here that we have the subsystem which will generate the trajectory, which is one of the right, which is the one on the right. So this block right here is what called the Simulink subsystem. And then we have our state flow chart here, which is the state diagram or graphical diagram. A lot of the different sequence or tasks that we are going to be following with our robot. Now, if we dig deep into the trajectory subsystem, we will see that we are performing in here a couple of different sort of algorithms. One is we are performing the inverse kinematics for the robot in order to go from the Cartesian space of the gripper to the configuration space of the robot for each of the individual joint positions. And then, in order to have a smooth transition of the robot from one position to the other, we are calculating a trajectory for those joints, which is why we are using transform trajectory algorithm provided in Simulink. And then finally, we are getting that information and publishing it through the ROS ecosystem in the corresponding, here, this one, ROS ecosystem in the corresponding ROS topic for the trajectory controller in the Kinova robot. And now if we keep taking a look at this Simulink file, you can find the Stateflow chart. This is what the state of the machine looks like in Stateflow. We are performing a sequence of commands here that serve as a template. In this case, we are just initializing the robot configuration. Then we are controlling the gripper, whether it's open or closed. And we are moving the robot to different location. So we are initializing the robot. First, we are initializing the robot in the state, this part. And we are sending the trajectory command after. Then we are telling the robot to move forward, which means we are changing the desired gripper position. After that, we are closing the gripper using this function available here that we are created in the Simulink ecosystem. And finally, we will be sending the different command in order to move the robot backwards. Close gripper and move backwards. And we will wait for a set amount of time, and then we will just let the robot be idle since it's finished all its tasks. And you'll see when we run the Simulink simulation, which is connected to the Gazebo environment of the robot, when the Simulink file or the Stateflow chart gets initialized and started, we will be able to see the respective state. And it's also showing us in this pop-up window, all right. The information coming from the sensor, which are our RGB camera and our depth camera. So we can see on the left here that we are currently in the initialized state, this part, which is being highlighted blue. And as we keep looking at the demo, the highlighted state will go to move forward and to close the gripper and then to move backward. And you can keep an eye on the robot on the right as it starts moving, corresponding to this desired behavior. Move forward. So we see that simulation is currently approaching the 5-second mark, which means that the robot is now attempting to move forward. The trajectory has been sent, and you can see on the images which are now shifting. They're shifting towards the correct forward direction. Then the gripper is closed. You can see the gripper is now closed. And then the new trajectory is being sent in order to move the robot backwards. And then we will see the image starts coming back the other way. Now, if you see the bottom of the Simulink file right here, we can see how to obtain the sensor information and Simulink as well. And you can couple this information right here, even though we are right now only visualizing those images. You can input those images into your algorithm and then use those to make decision on what you want your robot to do. There's more getting started resources available, and you can always email the MathWorks team. You can email us to the robotics arena at mathworks.com. It's also available throughout the homepage for the challenge. If you're new to the environment, we have the on-ramp courses as a part of the MathWorks free training, so you can learn about MATLAB, Simulink, Stateflow, and deep learning. If you want to include deep learning in your image classification tasks, and this training is good tool for ramp you up. The training can be taken from anywhere and takes around 1 to 2 hours. There is also an available pick and place example in our documentation that will show you how to process those images and depth images from the sensors, the cameras, in order to implement different heuristics within the points cloud processing to identify objects. And in this case, you can reuse some of the algorithms in there to help you identify the bottles and cans. You can see some images with that here on the screen, and it will also show you how to use different motion planners for your robot in order to avoid obstacles. In that particular example, the robot is trying to pick the objects, the cans and the bottles, in between two different boxes without knocking those boxes over. So if you're interested in implementing an obstacle avoidance algorithm for your robot, this example will also be pointing you in the right direction. And finally, please check out the MATLAB documentation, which will have great examples that you might need for this challenge, including robotics programming and simulation from the robotics system toolbox, processing images, both color images and depth images, and point cloud from the computer vision toolbox. Some more details about the participating and registration for the challenge participation in this challenge is optional and free if you are already registered to any other RoboCup leagues. If you are not registered any other RoboCup league, you can still participate in the challenge at a reduced fee. So you can just go to the home page and you can register and pay a discounted fee only in this RoboCup virtual manipulation challenge. We ask you please complete the pre-registration form so that we know who is participating in the challenge. And then you will have to submit your files and your video for the qualification round, which is on May 28th. And then we will process and score all of those algorithms that come in. And we will select a subset of the participants to be the finalists. The finalists will get a second chance at improving their algorithm to participate in the RoboCup finals from June 22nd to the 28th. And we will be notifying everybody who becomes a finalist, and there might be some slight changes to the environment depending on the quality of the submitted algorithms. I think for the moment, that is all the information on this challenge. So thank you for listening. Please feel free to ask any questions. Even if you do not have any questions right now, you might come up with some questions once you start using them. So you can email to us later too. And all of the rules are written in the homepage, so you can also check it. Thank you. So
yeah, thank you. So thanks for the very comprehensive, and also like I think like you have given all the information needed to join the competition. Right. Is there any like additional information from other colleagues? All right. So, yep.
Oh no. Thank you. Yeah. This is the end of the presentation. Yeah.
Okay. Right. So I guess you already take down the email address. So I will switch to my screen and continue some information. Okay, so I guess it's back to my screen now. Okay, let me get rid of this. Okay, so maybe like some of you or maybe most of you that joined this session may be new to this RoboCup activities or RoboCup competition, and also the MATLAB challenge and so on. So just in case like you are not familiar with RoboCup activities, like you are not sure what is the requirement for you to join, or you are totally like different from this community and come from other community and interested to join this, and also like maybe some of you might be the first time that you interested in MATLAB and you want to use MATLAB, and you come across this news and you want to start on. So I can provide you some more information for you to start on, because like from my understanding in RoboCup at Home Education, our community, most of the teams, they are new teams. So maybe you're not familiar with RoboCup, you're not familiar with MathWorks. Okay, so I will give you more information to see how you can link this topic that we discussed today with RoboCup. Okay, right. So over here in RoboCup at Home Education, we are also running this online challenge 2021. And both online challenge 2021 and also the challenge by MathWorks, these two, the virtual robot manipulation challenge and this online challenge 2021, they are both activities in what we call the RoboCup 2021 International, okay, which is going to happen in end of June. So just now, I think you already like take down the date is 22nd to 28th June. So during that week, we will have what we call the RoboCup 2021 week. Okay, so we will run a lot of different kind of league activities during the session because this year everything is run online. So we have the online version of RoboCup, because in normal year, I mean like in previous few years, we actually have face-to-face on-site competition. But starting this year, we actually have this online competition. So if you want to join any of the RoboCup activity, including this virtual robot manipulation challenge, you need to join the RoboCup 2021, right? Okay, so let's say like you are not so familiar with RoboCup 2021. So all you need to do is you just go to you just search from Google and you can find the website for RoboCup, or you can also access from our site, okay? So the screen, I already put up the information that you need. So MathWorks somehow is MathWorks is the global sponsor for RoboCup, and also is our technical partner in RoboCup at Home Education. So we are actually running this event together. And if let's say you are developing the system for the virtual robot manipulation challenge, I welcome you, or we welcome you also to join the RoboCup at Home Education Online Challenge 2021. So with the same system that you develop, you can also join the Online Challenge 2021 without any changes of your system. All you need to do is you just need to do very similar, like because you already produced the video and all other materials, you can actually submit the materials according to our requirement in Online Challenge 2021, and then you can join another one more challenge for your so that to increase your chances for more award. Okay, and by joining this Online Challenge 2021, so you are also entitled to the RoboCup 2021 fees, which is once you join this, you just pay one fees, you can join 2 events, and you have double your probability to get award. And for the virtual robot manipulation challenge site, you will get, like just now what Iijima-san said, you will get like the research grant, so you have the chance to win up to like 5,000 USD for the challenge. And over here for RoboCup at Home Education Online Challenge 21. So if you join the challenge over here with the same materials, you will have the chance to win the award in the RoboCup site as well. Okay, so that is a win-win and a bonus for you. With just one effort and also one registration fees, you can join both. Okay, so just now a few more information that I would like to add. Like just now, also we say about the complementary software. So MathWorks as a sponsor for RoboCup activities, so all the teams that work on RoboCup activities or challenges is eligible to apply for this complementary software. So just in case you are new to MATLAB or Simulink, and you would like to try on the software. Okay, so as part of RoboCup registration, registered team, or you join any of the activity which is over here, you join this virtual challenge or the Online Challenge 2021, you can apply. So on the screen, I already put the link there. You can go to the link over there and you request as one of the RoboCup team. Then you will get the complementary software from MathWorks, which is the MATLAB software, and also the Simulink software, which is using the software you can start your development for the development that the invited speaker today just explained to you previously. Okay, so now you start from the software and you can develop your robots and you can join the competition. Okay, so for more information, I already put out the QR code there. So once you scan the QR code, you will go to our Online Challenge 2021 website. Over there, you can see all the information about our online challenge. Basically, it's also it's a service robot development competition, which is on our site. It's more on the physical robot competition, but we also allow and also we welcome the virtual robot manipulation entry as well, because we know that in this online version, we actually allow the teams to join in just even with like the virtual robots and so on, because we understand the condition, but we want to encourage more people to develop robots rather than get constrained by the situation. So feel free to check out the information and also to apply for the software, and then you can start to develop. As for us, we are focused on the education side. We hope more people can join and also learn from these activities. Okay, so I already put out all the link, and just in case you miss the link, you can always go back to our course material site and you can find all this information and all the link over there. Okay, right. So okay, so we already almost the time. So we already reached the last slide for today. So I already put down all the links that you might be interested. So the first one is our invited lecture series. So from there, you can access to all other links actually. Then for the online challenge that I just mentioned, okay, so for the online challenge 2021, you can find over there. And from there, you can find the information and also the MATLAB, the virtual robot manipulation challenge link as well. And then if you want to get access to our learning materials, and also you want to join our community in order to have some interaction with us, please feel free to visit Robot for All, which is our partner for this learning and also community site. And for all other information, so just now Nobu already showed you the contact for the MATLAB challenge. So over here, if let's say you have any question regarding RoboCup or the Online Challenge 2021, feel free to contact us as oc@robocup@homeeducation.org. So OC stands for Organizing Committee. So you will reach our Organizing Committee for all other RoboCup related inquiries. So this the information that you need to join our activities. Okay, so now we already finished our presentation. would like to switch to our interactive session for some question and answer. So may I once again invite our colleague from MathWorks to come over and we can answer some questions. So maybe start from me. I have some question to ask you. All right. So for the attendees, let's say if you want to ask any question, feel free to, you can just turn on your mic and ask, or you can also write in on our interactive Q&A page, which is over here. Okay, so I saw, so I filled the pre-registration. Will I be contacted by a RoboCup organizer to confirm if will be able to participate? Okay, so maybe this one I need to ask Jose or you guys, because they already submit the pre-registration. Yes.
Yeah, Jeffrey, I can answer that question.
Okay.
You can email April at RoboCup just to confirm that we've received your information. But other than that, you should be, if you submitted your pre-registration, you should be all set to submit your results in May 27th when we're collecting the code for the submissions. As long as you're part of RoboCup and you've already registered for one of the leagues, then there shouldn't be any other requirements that you need to meet.
Okay, Jose. So just I just want to reconfirm with your answer. So which means after they send the pre-registration, will they receive any email contact from any of you guys or from RoboCup side?
No, there's no confirmation email. Feel free to email us if you're wondering if we have your information. But other than that, you'll be all set just by submitting the name of your team. As long as you submitted the right email address, we will send you the submission details right before the submissions are due. So that's what the pre-registration is for, so that you get the information.
I see. Okay. So roughly when you will send the information for the submission, like maybe
the week of the submission, we'll send the information. Yeah.
Okay. All right. So for the participant who already signed up for the pre-registration, you will receive the instruction for the submission near to the submission date, right?
Yes. Okay. It's just going to be a form, and where you're going to be able to fill in the links with the link to your code and the link to your videos. So that's all it is.
Okay. So maybe one question that always people ask me. So how are they going to submit those files actually?
I believe that is part of the instructions. So okay. I think in the instructions it says that you're going to need to provide a link to your files and a link to your video.
Okay. All right. Okay. Yeah. So so I think over here is very clear that you need to prepare your file online and they will download from the link. But please refer to the information from the email when they ask you to submit the materials. Okay. So you will receive an email for the instruction for the submission. Okay, so I think that is very clear for everyone. Okay, so is there any other questions? So you can feel free to write here, or you can turn on your microphone and you can ask. Okay, right. So if you have no other question, maybe some question from me. So regarding the MATLAB challenge or the robot manipulation challenge. So is there any other way of development outside, or they have to do everything within the MATLAB and Simulink? So for example, if let's say they already have some algorithm outside of the MATLAB ecosystem, for example, they work on something on the ROS side. So is there still possibility that they can use the algorithm from the ROS side to work with the MATLAB side? to make with MATLAB and Simulink side?
Sure. Yeah, that's a great question, Jeffrey.
Yep.
Well, yes, there are limitations. So the limitations are that the scoring will be done by the judges, and the judges will be running their code in MATLAB, right? So they will be running their code in a MATLAB installation connected to the virtual environment that they have access to. So as far as standalone ROS nodes that would have to be deployed into the OS itself, that's likely not going to be able to be an option here. But if you have libraries and if you have code that you've developed or that you're grabbing from somewhere else, and you can bring that into MATLAB and Simulink via, let it be C and C++ code or precompiled library or something like that, then you're welcome to include that as long as it's going to be reusable within the shared files, right? As long as all of the dependencies are contained in that file that you're submitting.
So which means they have to install in the Ubuntu environment in the virtual machine. Is that what you mean?
Nothing that has to be installed in the virtual machine would be an option here.
Okay.
Only things that are compiled on the host, only maybe precompiled libraries that are going to be run in the host. I think that the key part of this answer is we will be running your code in MATLAB. So, or the judges will run your code in MATLAB. So the most important thing is to make sure that your code and all the dependencies that you want to include with it are self-contained and will run in a specific version of MATLAB. And there's instructions for that in the participation guide, which will show you how you can use MATLAB itself or any other tool if you want to make sure you have all the files that you are running on your end, like dependency analyzers and things like that.
I see. So which means the dependency and everything, they have to submit the dependency in a self-contained format as well, that they can send to you and you can run as a self-contained software, right?
That is correct. Yeah, that is in the instructions. So anybody can go back and look at it. But they will be submitting basically a source code, and that source code needs to have everything it needs, other than MathWorks products, which they already know that will be available, in the installation.
Okay, right. So yeah, that because like that day I was like discussed with some potential participant, which is some groups they are interested to join. So I have the discussion and they have some question which is I'm not able to answer. So I'm going to ask today. So that is one part. And then also they are, okay, I think this might not be allowed, but I will try to ask if possible. So there are teams that work on other grippers. There are teams that work with other sensors. So is it limited to whatever sensors and grippers that is available in the template?
Yes, absolutely.
Okay.
Yes.
Right.
So it is limited to the sensors we've provided in the virtual machine. And the reason is, like I said, that your algorithm will be tested on a third environment, like Nobu explained. So that third environment is not going to look anything like the first two. So for us to be able to guarantee that, it means that the environment has to remain the same, which means that no sensors will be added. It's just whatever's available, which is essentially the two camera images available. Of course, you will have access to some of the ROS information from other messages. So if you're interested in something like that, then those will be available. Those are available in as part of the ROS communication infrastructure that is contained in the virtual environment. So those you can also use if you're interested.
Okay. All right. Okay. So I think that is very clear. So we need to use the default template for the robot model and also the sensor that's already available there. Okay. Right.
Yeah.
So
you can certainly use other ROS topics that are included in the machine.
Okay. Right. Then one more question is about the learning of the object, because like some teams they use some learning techniques. So which means they can use the environment provided to learn the object. So for example, like they want to like try to identify the object and so on. So they have to do the learning. Is all the learning and everything have to be how to say, be provided, or they just need the, like, after finish the result, they just submit the learning result?
That's a good question, and I think I understand where that's coming from. And the answer to that will be there's I guess two approaches to like robot learning. One of them which will be gathering a bunch of data, creating whatever algorithm it is, and training it offline, and then having sort of an executable version of it, which is like a predictor. Let's call it that is the thing that actually runs in the loop. And then the other approach is sort of doing it online, like as the robot is, moving, it's gathering new information and changing sort of parameters within its behavior. And I think there's no limitation here as to whichever one you're trying to do. What I will say is that it will be a lot more deterministic if you go with some sort of offline training method where you provide an algorithm that's already been tuned, that you already know its performance. Otherwise, it would leave a lot of variables to be determined. And also in general, algorithms that are constantly trying to readjust are going to be a lot more computationally intensive. And for this particular challenge, it will be beneficial for you to be able to run at a quick pace, run your code at a quick pace, especially since you don't know just exactly how it's going to be judged, since it's not going to be the same computational environment, right? It's not going to be run on your computer. It's going to be run somewhere else, which you don't know the compute capabilities of it. And two, because of course it can affect your score, right? Trying it on an environment. So it's a lot safer to have something you have some sort of benchmark on. Does that answer the question? Is that good enough?
Yeah, I think so. But it's just that because I also not so familiar what kind of file or they what kind of learning techniques that they use. Because like the learning techniques that I know, it's just sufficient to by sending that. But maybe I'm not working that part for MATLAB that much, so I'm not sure like what version of stuff that they're talking about. Right. So, but yeah, I think like I got what you mean, and I think this video recorded, so I can just play this video again for them to understand your answer. Right. So this is one of the thing, and I have one more question that from one team is like they have some strange how to say they just afraid that their code is not working after they submitted to you because of some configuration change, which is they are not how to say, not intentionally like modify, right? So for example, like they already have some preset in their PC, and when they run all this thing, and when they submit, you have some error, it's like you can't run and so on. So are they going to have some chance to do the rectifying, or that's all for them? So which means, is there any way that they can verify their submission beforehand, rather other than the tools that you provide them? Is that possible, like they can submit you, and if let's say you have any problem, you can reflect back the problem to them, and they can submit you the second version, which means before the submission date, or any arrangement that you can do?
Okay, so there's sort of two quick answers to that. One is that the best and easiest way for you to verify your code is to just try it on another computer. Honestly, if you're a team, just run it on 2 different computers. You're gonna see if there's any dependencies that are needed. Follow the instructions for getting started and for installing the virtual machine, because those are exactly the instructions that the judges will follow to run your code. So essentially, just run it on a clean computer that has MATLAB on it, install the virtual machine, and then see if you run into any errors. The second answer to your question is if we are, while the judges are running this code and the files, yes, they may reach out to you and give you the opportunity to fix something, depending on what the error is. If it's an error message within the tools, that's pretty obvious that something was not done correctly, or we see unfinished files, then we're likely not going to reach out and give you a chance to resubmit a newer version. But if it's a dependency that wasn't included, that looks like it was a mistake, or yep, then we might reach out to the team and ask for guidance on how to run that. But for the most part, I will say assume that you have to provide everything, because that is the case. So try it on different computers, ask your teammates to try it on different computers, see if any errors come up, and work through those before you make your submission.
I see. Okay. All right. So I think this is clear. But yeah, they also mentioned, like, if let's say when you run on your machine and so on, if let's say something that different from the video that they submit. So that means like whatever that you run, the result that you obtain with their code, and also with the result that they submit in the video, because like they want to ask like what is the purpose of submitting the video. So if let's say like you submit the result and you run, and the result actually differ from the video. So maybe in this case, it's like they got difference, or one is failed to run fully, but you got result in the video. So will the video help them to do some judgment?
Yeah, certainly. So the video is there to help the judges know that the code has already been successfully run in the past, right? That is the essence of the video. So that way the judges know that what to look for when they run the code. And it is true that the robot may interact differently, and it will. The robot will interact differently because it's going to be a different environment, right? But the video will give the judges a benchmark of what it looks like in one of the provided environments, right? So it basically lets them know, one, that all the code was working fine when it was submitted. Two, it gives them an idea of what the robot is supposed to do when the code is run. And finally, three, in the case that you are missing some files in your submission or something like that, then we have a verification that your code was running at some point, and it will give the judges an incentive to reach out to you and say, hey, we noticed that your code was running fine. It seems like this is happening. Do you have this last dependency that you missed or something like
that? Okay. All right. So the video will actually have tested on their side, right?
Right. Right. And the video is to make sure that people don't submit incomplete code as well, right?
Yeah, but I think it's fine. So we understand the answer from you. Okay, all right, okay. And one more thing is about, so what they can expect during the final. So are you going to run the whole thing?
Hey, Jeffrey, I think there's a connection issue. I don't think I can completely hear the questions.
Jeffrey, you might want to turn off your camera. We might have lost Jeffrey for the time being, perhaps. Jose, are you still there?
Yeah, I am still here. I think we might have lost Jeffrey for a moment.
We'll give him a couple minutes, but we did receive a couple more questions on that page. The first one's pretty simple. What was the contact email again? I don't know if one of you has it readily handy, but that's roboticarena@mathworks.com, right?
Yep, it's roboticsarena@mathworks.com. And if you have questions about the registration, the email is going to be april.robocup@gmail.com, and it's in the homepage.
Right. So if you Google search virtual robot manipulation challenge, then you should be able to find the webpage with all this information. And while we're still waiting for Jeffrey, another question that we had, Jose and Nobu, is there was an attendee who just found out about RoboCup, and they're wondering how to get started in order to participate.
If they're wondering how to get started with RoboCup itself, I think Jeffrey might have a couple of links that he can share with them. If you're just finding out about the challenge, this RoboCup virtual manipulation challenge, it is not too late to get started. It's perfect timing for you to get started. The templates make it really easy for you to just start working on your own algorithms. I would say the only thing is to get pre-registered and contact RoboCup. If you are not part of RoboCup already, to take care of the registration and the registration fees. And then you can contact us with any further questions you have about the challenge. There's a document. Once you read through the participation guide and the document, it will cover all the things we covered in the webinar and more.
Great. Thanks, Jose. And thanks, Nobu, for sharing the screen. I think that's all the questions that we had on that channel that Jeffrey put up.
Yeah, I think that's all I see for now.
Right.
Okay, so I don't know if it's us or if it's Jeffrey who's having connection issues, but I think on our side, thanks everybody for attending. I hope you guys enjoyed this challenge. We're really excited to see your submissions and your participation on it. And from MathWorks side, looking forward to seeing all of your code.
Right, sorry, I'm not sure if I'm back. Can you
you're back.
Yes, Jeffrey, now you're back.
Okay, I'm so sorry about my network connection. I'm not sure about the recording. I hope like it's still running smoothly. Okay, so let me put things back. Okay, so maybe I will refrain from my slide. I just turn on my view cam so that you can still see me. Okay, so I guess like we already finished all the content. So is there any things that you want to add on your side, Jose and also like Iijima-san?
No,
Yes,
not
Jeffrey,
from my
thank you.
end. Yeah. Thank you.
Okay, so is everything okay? Right.
Yes.
We just
So
answered a couple of the questions from the
all right,
the website
so,
you posted, so I think we are all good to go on questions.
okay, so we already like finished all the Q&A, and I hope everything is okay. So with that, thanks yeah, Iijima-san for the invited talk, and also our fellow colleague Jose and also Fred from MathWorks to join us today to give very like interesting, I think, like activity. So we look forward for the RoboCup event and also for the virtual manipulation challenge in the RoboCup. So if if you still have any other question that you would like to ask, you can feel free to add in the interactive Q&A, or you can email to us, or either way we will try to get contact with you. But of course, the only way we can contact you is if you leave some contact number or your email address so that we can contact you. So I think the best thing is like you email to us. Also, it's either you're using the OC email address, or you can write to MathWorks regarding the manipulation challenge. Okay, so with that, I think like I would like to conclude the session today. So is everything okay? So can I, yeah, just to say bye with all of you over there in MathWorks. So can I like, yeah.
Yeah,
Everything
this is
okay?
fantastic. Yep. Thank you very much for your time, Jeffrey, and everybody for joining.
Thanks. All right, thanks, Fred.
Jeffrey.
All right, thanks, Iijima, and also thanks, Jose, and thanks for all the people that attend today. I'm so sorry about the slightly glitch just now, the technical glitch that I get offline. So I will, hopefully the video record is not affected. I'll try to see after this, and then I'll see you again. So hope you can sign up for the competition, and I will send out, like, we have more invited lecture series coming, so I will send out again. And for today, for those who register, later on you might receive an email regarding all the information that we shared today. Okay, so with that, I would like to close the session today. Thank you very much.
Thank you very much.
Thank you very much.
Thanks, everybody. Have a good one.